Welcome to Code 2 Data AI Network. From algorithm to hardware, a distributed binary search system explanation. What if an algorithm could express its reasoning physically? Binary search is typically invisible. It runs inside memory and returns a number. This project transforms it into a distributed system where backend logic drives hardware in real time. One architecture, multiple layers. Here, the architecture we provided collects input from the front end. Then backend computes binary search. Each midpoint is sent over HTTP to an ESP32 device. The LED matrix scrolls the midpoint. The OLED shows the target value. The backend finally returns the index to Angular. OLED target value 4. Now explore the debugging process of Micronaut, controller and return flow. The controller exposes the REST endpoint. It delegates to the service layer and returns the final result to Angular. The return value is the index of the target or -1 if not found. The midpoint is calculated using an overflow safe formula. Because in Java int, max value is 2,147,483,647. Suppose left equals 2 billion, right equals 2,100,000,000. Now if we do left plus right equals 4,100,000,000. This is bigger than int to limit, so Java wraps it, wrong negative number. To avoid this issue, we using the safe formula in that right-left, always be small, then left plus that small gives safest 1. Then each iteration sends the midpoint and target value to ESP32 through send index. Flow. The search space shrinks until a match is found or exhausted. The final result is returned to the front end. Previously, you had found one method calling from ESP32. Here you got stuck how it communicate with ESP32 microcontroller. Now let's go and explore the reality behind it. In Arduino programming, there are only two primary functions, setup and loop. Setup runs once at startup. Used for initializing Wi-Fi by collecting the password and Wi-Fi num that we provided, starting web server with server.on and server.begin, as you had seen through, initializing OLED and matrix displays through set intensity, clear display, display, and begin. Registering routes like server.on index, handle index. This does not call handle index. It only registers that if someone later calls /index, handle index should run. Loop. Video Arduino IDE loop. Runs forever. Used for listening for HTTP requests through server.handleClient. Continuous task to T constantly checks if a request has arrived. When a request arrives, it matches the path and calls the registered handler. The flow actually looks like setup, runs once server.on, registers route loop, runs forever, handle client, detects request, path matches /index handle, index, executes. This function void handle index is executed whenever the ESP32 receives an HTTP request at the path index. It acts as the request handler for incoming backend updates. Void handle index defines the function that will handle requests routed to /index. It does not run automatically. It only runs when a matching HTTP request is detected. If server dot has arg value and server dot has arg target. Before processing the request, we validate that both required query parameters are present. This ensures the backend sent both the midpoint value and the target value. Without this validation, the system could attempt to access undefined parameters. Then extract midpoint by mid-value equals server.arg open parenthesis, quote, value, quote, semicolon. This line extracts the midpoint from the URL query string. For example, http://192.168.1.45/index $value equals 3 equals 7 getting from if the URL contains value equals 3. This retrieves the string 3. The value is stored globally, so the LED matrix can animate it in the main loop. Extract target value by string target value equals server.arg target. This extracts the target value from the query parameters. Unlike the midpoint, the target value is immediately used to update the OLED display. Trigger animation flag. Instead of triggering animation directly inside the HTTP handler, we set a flag. New mid received equals true. The animation logic runs safely inside the loop function. This design keeps network handling and display animation separated. OLED and matrix display OLED.clear display and matrix.display. Clear, the OLED maintains a memory buffer. This command clears the previous content from that buffer. Without this, old pixels would remain visible. Update physical screen OLED.display parent, semicolon matrix.display text parents, send HTTP response server, send parents 200 comma, quote text / plain quote, comma quote, okay quote, semicolon. Finally, the ESP32 sends an HTTP response back to the Micronaut backend. The status code 200 indicates success. This prevents the backend from timing out. At this point, the midpoint and target have been received. The OLED has been updated, and the LED matrix animation is triggered in the screen. Here for your reference, we providing hardware mapping and Wi-Fi constraints. MAX7219 ESP32.
VCC connected to 5 volts. GND connected to GND-DIN connected to GPIO 23. CLK connected to GPIO 18. CS connected to GPIO 5. OLED connected to ESP32. VDD connected to 3.3 volts. GND connected to GND-SDA connected to GPIO 21. SCL connected to GPIO 22.
Also, while setuping the Arduino, we had faced some constraints in Wi-Fi module like it supports. Only 2.4 GHz supported. WPA2 recommended. Backend and ESP must be on same network. IP may change dynamically during ESP32 setup. The Arduino board manager installs the ESP32 core libraries, including Wi-Fi, web server, SPI, and wire libraries. These enable network communication, embedded HTTP server functionality, and hardware communication with LED matrix and OLED displays via board manager R1 ESP32 core. Library ESP32 by Espressif Systems 2 LED matrix libraries MD_MAX72XX control MAX7219 LED matrix hardware MD_M AX72XX, scrolling text animation on LED Matrix. 3. OLED libraries, Adafruit SSD1306, control OLED Display. Adafruit GFX, graphic support for OLED. 4. SPI library, SPI.H, communicate with MAX7219 LED Matrix. 5. Wi-Fi library, Wi-Fi.H, connect ESP32 to Wi-Fi to get IP address and enable network communication. This project demonstrates distributed system thinking. If you're interested in algorithms, distributed system thinking, system design, AI or IoT, follow this journey. Students and professionals with new ideas can join with us to build and explore the world of technology.